13.1, use trigonometry with right triangles. So this should look pretty familiar from geometry. This section in particular, but the first one say to evaluate the 6 trig functions of the angle theta. So
what is angle theta?
You're gonna see in just a second.
Oh.
I haven't even had time to draw a triangle yet. And we're given, this is 3, this is 8, and this is theta. So we have to, and this is marked as the right angle. So we have to find the other side, okay, whatever's missing for each respective triangle. Find what's missing, then we have to solve each of the 6 trig functions with that. So how would I go about finding this other side? See if we remember from geometry.
Pythagorean theorem.
So that's going to be 8 squared plus 3 squared is equal to c squared. So then we would just take the square root of this, which would be the square root of 64 plus 9, so the square root of 73. And we just leave it. Okay, we don't try to like reduce it, we just leave it as the square root. So then, I always set them up first so that I make sure I solve everything. And I want them in this order as well. It'll be more important later, but I should get you used to it now. So remember, SOHCAHTOA. So sine is opposite over hypotenuse, so 3 over the square root of 73. However, we're not allowed to leave it like this. Okay, we cannot have a radical on the bottom. So we have to multiply, and you don't actually have to show this step, you can just do it, but I'm going to show you for the moment. So we're multiplying by the square root of 73 over the square root of 73. So that's 3 root 73 over 73. Cosine of theta is adjacent over hypotenuse, so it's 8 over the square root of 73, which ends up just being, we're multiplying again by the square root of 73 over the square root of 73. I'm just going to draw an arrow to show that's what we're doing. So that's going to be 8 square root of 73 over 73. Tangent is opposite over adjacent, so that's going to be 3 over 8. Then on the other side, part of the reason for lining them up like this is because literally all we have to do is flip them. Okay, but I'm going to flip the original one so that I don't have another radical on the bottom and have to multiply and reduce and all that fun stuff. So I'm going to flip the original, so it's going to be square root of 73 over 3. Secant, square root of 73 over 8. And cotangent, 8 over 3. Any questions about that one? And then follow-up question, does this ring a bell? A little bit, okay.
For secant, did you just flip it like you? Oh,
Yeah.
okay.
So the ones that are lined up side by side, they just are reciprocals of each other. They just get flipped. And part of the other reason that I always write them like this, because honestly, I can just write this, like I've just done it for so long, like I don't even need to write this first step, but I pretty much always will, because when I go to flip them, then I don't have to like sit there, and then, because if I did that, then I would have, well, 73 over 3 square root of 73. Well, I can't have that, so now I have to multiply by the square root of 73 over the square root of 73. So that's 73 square root of 73 over 3 times 73, and then cancel. You know what I mean? Like, it just gets really long, so that's why I don't do that. So, or you can just know that it's, I mean, you can flip them and do hypotenuse over opposite, whatever. I mean, some people just like to memorize it that way.
Yeah.
I'm like, memorize the one thing that you already know and then just flip it. But it's totally up to how you feel it's easiest to remember. Let's see, another one like that. It's definitely not a right triangle. Let's see, this angle over here is theta. 8, and then the hypotenuse is 2 square root of 17. So I've got to find the other side first. Now, pretty much once, well, you know the Pythagorean theorem. You used it quite a bit last year, I'm sure. What I will typically do is go ahead and rewrite the formula. So I would go ahead and write this as a squared is equal to c squared minus b squared. Because what happens is, let me back up now. You have a squared plus b squared is equal to c squared. So I will just go ahead and go straight to, I know I need a side that's not the hypotenuse, so it doesn't matter if you choose a or b. It really doesn't. So a squared is equal to c squared minus b squared. You are more than welcome to go straight there with that. And it doesn't matter a or b. It doesn't make a difference. It's kind of like which one's your favorite, I guess. So, and a lot of times I'll even go ahead and go this far when I'm plugging in the numbers and just go ahead to save steps of writing. But if you need to write them all out, more than fine. So I have 2 square root of 17 squared. And then minus 8 squared. So 17 times 17 is 34. And then, no, wait. What?
Isn't the 17 in a square root thing, the radical thing?
Yes. I was like, what is happening? Yes, thank you. Yes, so that would be 17 then times 4, which is 68. So this is the square root of 68 minus 64, which is the square root of 4, or 2. So that side is 2.
I was just about to say, I'm like, are you going to Google for that?
Yes. All right, so then solving. All right, so what would sine of theta be? So I will tell you what I would personally do first is that you have a 2 top and bottom, so those can cancel. So then I would just have, just to make my life easier, so then you would have the square root of 17 over 17.
Okay.
But yes, what you had would reduce down to that.
Okay.
So then cosine of theta.
Eight over 2 square root of 17. And then
Can I reduce this first?
Yeah.
yes.
Okay. So I would reduce that first. And then what?
4 square root of 17 over 17.
Yep. And then tangent,
It's 2 over 8.
which is,
1 over 4.
yep. And then cosecant, we're just flipping it, but it's going to still reduce, so it just becomes the square root of 17. Okay, if you want to write 2 square root of 17 over 2 and then cancel, completely fine, but you've already shown that it's canceling, so there's no reason you don't have to write it. Secant would be what?
Four square root. No. Square root of 17 over 4.
Square root of 17 over 4. Because we've already reduced, so we're just taking it and we just flip it. And then cotangent would be 4.
So when we did the, like, multiplying the 2 square root of 17, like, when we were still trying to find the other side, so when we did that, did, like, the square take away the square root, and then you just square the 2, and then you multiply
Yeah.
it? Okay.
So this became 4 times 17.
Okay.
Yeah. Once I, put the square root in there. I was like, that number is not right. That's way too big. All right, so that's what happens when they give the stuff to you. Okay, the next ones that's going to happen is they're going to give you something like cosine of theta equals some fraction, and you have to set up your own triangle and solve, and you're solving for the other 5 trig functions. But I still want you to list out all 6 like this, and you'll just, the one that it gave you to begin with is just given. So it's like, well, you only have to find 5 more after that, basically. So something like 10 cosine of theta is equal to 5 over 8. So I'm going to draw a triangle. And it's very much a preference thing of which direction you draw your triangle. So if you're like, I like my triangles facing the other way, that's totally fine. You want it upside down? Totally fine. The book draws some of them like this. And it's a right triangle. It's weird. I don't know. Like, personal preference. Go for it. Sure. So I'm going to call this angle theta. So if that's the case, where is the 5 and the 8 going?
Is going on the bottom.
Down here?
Yes.
Okay. So that's the adjacent value, so it goes there.
And the 8 is going on
The slanted
that.
hypotenuse.
The hypotenuse,
awesome.
yep. So then, still need to find the other side. So how would I do that?
Modified Pythagorean theorem.
So I'm going to have a is equal to the square root of 8 squared minus 5 squared. You'll see the farther we go, the lazier I get with how I write the Pythagorean theorem. So this would be the square root of 64 minus 25. So a is equal to the square root of 39. Now, I will tell you, I kind of mentioned it earlier, but like, I do not often take anything out of my square roots once I have them, even though sometimes you can. Like if I had the square root of 8, obviously that can be the 2 square root of 2. I don't typically reduce them just because, I don't know. There's not really a reason, I just don't. Not wrong if you do, you're more than welcome to do that. It's probably technically more right if you do. I just like how the radicals look, so I just leave them. So, anyways. So, but all that to say, on occasion, sometimes when I'm grading, if I didn't go and like reduce them all the way, something might get marked wrong. So if not intentionally, I try to look and check if I notice that that's what y'all are doing. But if something ever does and you're like, oh, I think I reduced this correctly, just show it to me and it happens. So, all right, so now I know this side. So I can set up all my functions. So cosine was given to me, so I can just write that one in. So what is sine?
Square root of 39 over 8.
You said Riley grew to 2. I think you said Riley grew to 2. I was like, no. No, it's not. I got your turn in this class.
I think it is your turn,
It's your
though.
turn to shine, Riley.
Yeah.
Riley's like, yeah, I'm not really feeling the whole taking turns thing.
Oh.
We can leave that in 3rd grade.
What's tangent?
Square root of 39 over 5.
Riley, it's your turn. No.
It might be better.
So cosecant of theta would be what?
8 square root of 39 over 39.
8 square root of 39 over 39. And like that's absolutely fine the way that you said that, like to just go straight there instead of having to like show out the steps and stuff. Secant
8 over 5.
and cotangent.
5 square root of 39 over 39.
Yep. All right. Let's see. Another one like this, or any questions about anything we did with that one, setting it up or anything? All right. So the next one, we're gonna have the cosecant of theta is equal to 10 over 7. So obviously, I would say always draw your triangle first, but sometimes when it's cosecant, especially when you're not really used to it, you're sitting there thinking, okay, well, cosecant is the opposite of sine, so I need to figure out, where everything goes or whatever. Sometimes it's easier to actually go ahead and list out all of your stuff over here. And say, okay, I was given cosecant to be 10 over 7, so I know that. So that means that sine has to be the opposite of that, so it's 7 over 10. And then you can go, okay, well, that's something that I recognize, so I can make sure I get things in the right place. You can obviously go ahead and set it up for cosecant and just do that if you want. But sometimes I think people find it easier to find the one that you're used to working with, like a sine, a cosine, or a tangent, and switch it before you do that. So that being said, what numbers are going where? On my chart.
7 goes on the straight line.
Over here?
Yes, and then 10
All straight,
goes on
Jenny.
the hypotenuse.
Yep.
You know, they're all straight lines.
Well,
I knew what she meant. I could see her doing this. I knew what she meant.
I meant like up and down. The vertical one. Yes, that's what I meant. See, Riley, you so good.
All right, so solving for the other side, how do I set that up?
Like the previous problem.
Okay, so tell me what's going where.
So you have A, and then the equal sign, and then square root of is 10. Yeah, 10 squared minus 7 squared.
So that is the square root of 100 minus 49. You'll see once I get really lazy, I go straight to that step. If it's something that I just like, a common one. The one that was like 2 squared to 17, no, I wouldn't have just gone straight there. But, so that ends up being the square root of 51. So then with that, what is cosine?
The root of 51 over 10.
Square root of 51 over 10. Tangent.
7 square root of 51 over 51.
Yep. 7 squared of 51 over 51. Secant.
10 square root of 51 over 51.
That's exactly what I was gonna say.
Good job, Riley.
I was like, everybody kept telling Riley it was her turn, and I thought she was about to just.
turn. Where's
Full-
my turn?
Well, do
You
you want
want the
cotangent?
Riley's been thinking about that one.
Actually, maybe.
You got it, Riley.
Speed.
Square root of 51 over 7?
Yes.
I'm so proud of you, Riley.
Oh. So smart, guys.
Oh, I thought you were disappointed that I was bad.
It's always so exciting, like with when we're doing trig stuff, when all of a sudden everything just clicks, because that's like it's like all of a sudden it's like everybody's like a little light bulb above their head, and all of a sudden it just starts glowing. It's like, oh, they get it now.
It's like you see the shimmer behind their eyes.
Yeah. It's like, oh, they got it.
Finally.
All right. So these next ones say to find the exact values of x and y. So 18, and of course it's one of their little upside down triangles. It is a right triangle, whether it looks like it or not. Kind of looks like a little mountain. And they give you that this is x, this is y, this angle is 45 degrees, and this side is the square root of 21. So my first question is, does this look like anything that you know?
Yes.
Okay, what?
It's one of those special triangles.
Okay, what is the special triangle?
It's like the 45, 45, 90.
Yep, so it's a 45, 45, 90. So what I'm going to do is I'm going to actually draw the triangle with the special values in it. Okay, so it was 45, 45, and then obviously 90. What do you know about the side lengths of a 45, 45, 90?
So the non-hypotenuse legs,
Mhm.
the legs are equal.
Okay, what are they? In the generic, most basic form, what are they?
I'm pretty sure there's a square root of 2 somewhere in this.
Okay,
whole thing.
that is one of the values. one of the other values is 1.
Yeah, I
So
think
which
that-
one would go where?
So square root of 2 is the hypotenuse.
Yep. So this is going to be square root of 2, and then the others are going to be 1. So I want to basically use this triangle that I have the known values for to help me solve the other triangle. Okay? So do you remember proportions from like way back in early Algebra 1?
Maybe.
Sure.
Cross multiplication, be the
Oh,
pretzel.
Yes.
Okay. So basically that's what we're going to end up doing. Okay? So we are going to say that basically y over the square root of 21 is equal to 1 over the square root of 2. I'm trying to get equivalent values basically. So then I can do the fancy little pretzel and multiply. So I have on the left square root of 2 times y, and on the right I have the square root of 21. So I obviously need to get y by itself, so divide by the square root of 2, so y is equal to the square root of 21 over the square root of 2. But we can't leave it like that. We can't have the radical on the bottom. So we're multiplying by the square root of 2 over the square root of 2, which gives us the square root of, remember when we're multiplying two square roots, we can multiply what's inside of them and leave it all under a square root. So that's going to be the square root of 42 divided by 2. Now, because of what kind of triangle this is, what does that also mean about x?
It's the same.
So x and y are both the same, so they're both equal to the square root of 42 over 2. Any questions about that one? The 45, 45, 90 is definitely the easier one. Now, your book is just oh so generous and gives your both odd problems to be a 30, 60, 90 triangle and the even one to be a 45, 45, 90. So I don't normally do odd problems, but sometimes in trig I will have to do odd problems just because of how it falls. So I am going to work one of the odd ones so that you can do the other one for homework so that you can see basically what to do. And we'll probably stop after that one for today, and I'll let you go ahead and start on the homework. And then tomorrow we'll finish the section, and you'll have time to work on it. Most trig sections we'll spend 2 days on, be it if I teach the entire class period and then you have the entire next day to work, or if I split it in half and teach half, give you a little bit of time to work, and then teach the other half and then give you the rest of the time to work.
Is that why
So.
we only go over 2 chapters? Or is trig just fully just 2 chapters?
There's only just 2 chapters in the book for it. So, yeah, most textbooks, trig is 2 to 3 chapters. But chapter 14 is longer, so that's one that could be broken up into 2 chapters in some other textbooks because it's just longer. So, 19 is the one that I'm going to do. It's upside down, but it at least looks a little nicer. So, they give us side length of 12, 30 degrees, y, and x. And I already told you it's a 30, 60, 90 triangle, so this other angle is going to be 60 degrees. So I'm going to do the same thing. I'm going to do a comparison triangle just so that I can see it. So I'm going to set up another one. That's a 30, 60, 90. So now my question is going to be, do you remember what values go with a 30, 60, 90?
There was a square root of 3 somewhere.
That's the big one, the big long one at the top. Yeah.
This one?
The, yeah.
And And the hypotenuse is 2, and then the small one is 1.
Yep. And remember,
Good job.
side lengths match up with their angles. So the smallest angle should have the smallest side. Biggest angle, which is your right angle, should have the biggest side. So sometimes people give them to me backwards, and I'm like, did you even look at your work? That doesn't make sense. And they're like, oh, I forgot. Yeah, okay. So we're going to set up a comparison again to do this one. So I'm going to do 12 over y is equal to square root of 3 over 2. And it really doesn't matter as long as you're picking the same values from each triangle to pull from. It doesn't really matter which ones you pick. So when I be the pretzel, I have 24 is equal to square root of 3 times y. So then divide by the square root of 3. 24 over the square root of 3 is equal to y. I'm going to actually switch to the y to the other side so I can just work my way across. So when I multiply, that's going to give me 24 square root of 3 over 3. But I can reduce that, so I'm going to. So 24 and 3, that's 8. So 8 square root of 3 is y. So this one's not as nice. Obviously, x and y aren't the same. So sad. So I'm going to, let me focus, this is getting blurry. So I'm going to have to do a second set of math this time. So I say 30, 60, 90 ones don't play quite as nice as the other ones. So I'm going to do, since I now know what y is, I can use that value. Now, if you're not very confident that it's right, you may not want to, but I'm going to be confident that I'm right, so I'm going to use it. So x over 8 square root of 3 is equal to 1 over 2. So I have 2x is equal to 8 square root of 3. Divide by 2, so x is equal to, well, 8 divided by 2 is 4, so 4 square root of 3. And it makes sense because over here, this is 1, this is double that. So I have my x value is 4 over 3, double that. That gives me 8 square root of 3, so that makes sense. So I have x and y there. Any questions about those ones? Anything? You will need your calculators tomorrow for the part that we're doing, so I don't know if y'all have charging calculators or whatever, but make sure you have that because it'll be kind of difficult to do the stuff that we're it'll be kind of difficult to do the stuff we're doing tomorrow if you don't have it. But up through where we are so far, the problems are 3, 11, 13, and 17, and then I'll add a couple more to that tomorrow. You don't have to finish them tonight. The way that the homework for this stuff will work, unless I say otherwise, is that when we're completely done with the section, it all gets turned in. But usually if I'm stopping with enough time for you to work on some problems, it's because it's good for you to get a foundation, make sure you know what you're doing before we move on to the next part of that section, because a lot of trig sections could really be two separate sections, so.